The first law that we're going to study is Boyles Law. Boyles Law states that pressure and volume are inversely proportional in a gas. Meaning what? If we increase the volume, the pressure decreases, and if we decrease the volume, the pressure increases. So in Boyles Law, we use the following equation. P1 V1 equals P2 V2. The temperature and the amount of moles remains the same. The pressure and the volume is 1 and 2 represent a change. We have an initial condition that we call 1 and we change and now we have it 2. As long as the two volumes and the two pressures have the same units, we don't have to worry about conversions. The equation will work. So in order to solve these problems, we have to organize a table, or organizing it meaning or understand which one is the initial condition, which one is the final condition. Rearrange the equation, substitute the values and do the calculation. So let's do a first problem. A sample of nitrogen has a volume of 4.2 liters in 1 atmosphere. So we grab P1 and V1. P1 is 1 atmosphere and V1 is 4.2 liters. And then the pressure change, so P2 is 0.75 atm, and we want to know the volume. We want to know the volume, V2. So for this, what we're going to do is write the equation. P1 V1 equals P2 V2. And we're going to solve for V2. In order to solve for V2, we divide by P2 in both so they can cancel out. And we arrive to the equation that V2 is equal to P1 V1 over P2. Now we substitute our values there. And we write V2 equals. The initial pressure was 1 atm. The initial volume was 4.2 liters divided by 0.75 atm, which is the final pressure, and V2 equals to 5.6 liters. When we inhale, the lungs expand, so the volume increases and the pressure in the lungs decreases. When we exhale, the volume in the lungs decreases, therefore the pressure in the lungs increases. Let's do another problem. We have Freon 12 gas. We want to know what will be the new volume if we had a sample that had 8.0 liters and its pressure was 550 millimeters of mercury, and then we change that pressure to 2,200 millimeters of mercury, and we want to know V2. So we're going to do exactly the same that we did last problem. P1 V1 equals P2 V2. We're going to solve for V2, meaning that we divide by P2 to cancel here. And V2 is equal to P1 V1 over P2. What we do now, we substitute and we write V2 equals, our initial pressure was 550 millimeters of mercury. Our initial volume was 8 liters divided by the final pressure, 2,200 millimeters of mercury. And then what we do the calculations, and V2 equals to 2.0 liters. The next law that we're going to study is Charles' law. This one states that when the pressure and the number of moles is kept constant, the volume and the temperature are directly proportional, meaning what? If we increase the temperature, the volume will increase. When we are doing gases and we're dealing with temperatures, it's very, very important that we remember this. Temperatures for gases must be in Kelvin. If they are not in Kelvin, the equation will not work. So, this law, again, in order to keep the pressure constant, if we increase the temperature, the volume will increase. If we decrease the temperature, the volume will decrease. So let's do a few problems. Let's do problem 7.5. This type of problems, we're going to do the same. We're going to set up our conditions, V1, V2, T1, T2. So we have a gas that is in 3.1 liters and the temperature is 12 Celsius. V2, we don't know, and T2 is 32 Celsius. Again, the first thing, because we're dealing with temperatures, the first thing is to convert these temperatures to Kelvin by adding 273. So T1 now is 294 Kelvin, and T2 is now, sorry, I made a mistake here. T1 is 285 Kelvin, and T2 is 305 Kelvin. So we set up the problem and we have our equation. V1 over T1 equals V2 over T2. And we're solving for V2. So we multiply here T2 and here 2, so they can cancel out. V2 is equal to V1 over T1 times T2. And we substitute the values. V2 is equal to V1 is 3.1 liters times T2 is 305 Kelvin divided by 285 Kelvin. And then V2 is equal to 3.3 liters. This problem, we have a condition of V1, T1, and V2, T2. V1 is 785 milliliters, T1 is 21 Celsius. V2, we don't know, T2 is 0 Celsius. Again, first step here, convert to Kelvin by adding 273. This case is 294 Kelvin, and in here is 273. So we have V1 over T1 equals V2 over T2. So what we're going to do, we solve for V2 by multiplying T2 here. They cancel out, so V2 is equal to V1 over T1 times T2. And we substitute. V1 is 785 milliliters, T2 is 273, and T1 was 294 Kelvin. We do the calculations and we end up with V2 equals to 729 milliliters.